Horizontal wells are drilled to produce oil and natural gas from long completion intervals which span thousands of lateral feet. Choosing the proper artificial lift system is crucial to effectively produce horizontal wells and to maximize the ultimate recovery of oil and gas reserves. Horizontal Lift Technologies, an innovator in horizontal well production, offers field-proven artificial lift systems to efficiently produce horizontal wells. The Horizontal Lift Technologies' patented dual lift system maximizes production from horizontal wells while reducing operating expenses for the life of the well. The dual lift system offers several advantages, which include effective operations within the extreme deviation of lateral wells, unloading lateral wells from the toe end, capability of producing gassy fluid and fluids containing solids, adaptability to changing production conditions, low cost of operation, maximizing ultimate recovery. The dual lift system downhole assembly begins with an engineered section of lateral tubing which is positioned to extend below the entire productive lateral interval. The Horizontal Lift Technologies QDL packer is attached atop the lateral tubing section and is set toward the base of the wellbore curve. Above the QDL packer, a string of production tubing is attached to the top of the packer and extends up to the surface wellhead. Specifically engineered lift gas mandrels are positioned along the production tubing above the QDL packer. A string of coiled tubing is also attached atop the QDL packer and clamped alongside the production tubing to extend up to the surface wellhead. This entire bottom hole assembly comprises the dual lift system. The dual lift process begins within a liquid-loaded horizontal well by introducing high-pressure lift gas through a wellhead casing valve and into the tubing casing annulus above the QDL packer. The injected lift gas displaces fluid from the annulus into the production tubing through the uppermost gas lift mandrel. Once the fluid level has been displaced to the first mandrel, lift gas enters the production tubing and aerates the fluid within. The lift gas decreases the density of the fluid within the production tubing, which in turn reduces the hydrostatic pressure on the reservoir. The annular fluid continues to be lowered as lift gas is sequentially injected into deeper mandrels. As the hydrostatic pressure is reduced from the upper wellbore, the lateral formation begins to flow and produce. Ultimately, the annular fluid level is lowered to inject lift gas through the lowermost mandrel set just above the QDL packer. High-pressure lift gas is then delivered from the surface wellhead into the coiled tubing injection line and to the QDL packer. The coiled tubing lift gas stream crosses through the QDL packer and into the lateral tubing, which delivers the lift gas stream to the toe end of the lateral. From the end of the lateral tubing, the lift gas enters the annular space between the outer diameter of the lateral tubing and inner diameter of the horizontal wellbore. The constricted annular space between the tubing and the lateral wellbore enhances the lift gas velocity along the horizontal section. This high-velocity gas stream effectively sweeps produced fluid from the entire lateral length and back toward the heel of the wellbore. At the wellbore heel, the combined production stream enters ports at the base of the QDL packer to be delivered up through the packer into the production tubing attached at the top of the packer. The combined production stream is then raised to surface with the aid of the injected lift gas entering the gas lift mandrels operating above the QDL packer. The combination of the upper lift stage above the QDL packer and the lower lift stage within the lateral wellbore comprise the dual lift system. The dual lift system offers the most adaptable and efficient approach in artificial lift for horizontal wells by incorporating enhanced velocity lift gas to unload fluid from the lateral, adjustable lift gas rates tailored to changing production rates and pressures throughout the life of the well, upper and lower lift stages, which can be adjusted independently and run intermittently, and the ability to inject fresh water or solvents across the productive lateral interval via the lower lift stage. The dual lift system has been field proven to cost-effectively maximize the ultimate recovery of oil and gas from horizontal wells. Please contact Horizontal Lift Technologies for an analysis and to apply the dual lift technology to your horizontal oil and gas development program.